Hello students, we recently did the flame test lab where we observed that different elements will burn with different colors. We also noticed though that some elements have very similar colors, making it difficult to tell them apart. So what we're going to do is we're going to look at the element's atomic emission spectra, which is going to allow us to tell those similarly colored elements apart. So just like white light around us can be separated into the rainbow by a prism, we can take the light emitted by specific elements and again use a prism to separate it into its specific frequencies. And so that's what we're going to look at today, and we're going to start by just recording some element spectra, and then there'll be some conclusion questions after the activity to answer in your packet. So right now I have the diffraction grating held in front of the lens of this camera, and if we kind of look at the fluorescent lights around the room, what we should notice is that when we look at them, we can see all the colors of the rainbow. So we get red and orange, yellow, green, blue, and then violet, and they all kind of nicely fade together. So pause the video if you need to and take a moment to sketch that particular spectra. If you look at sunlight through a diffraction grating, you'll see the exact same kind of color pattern that we saw with the fluorescent lights. What we're going to do now is we're going to specifically look at the spectra of a few different elements. And this black box that I have right here, I'm going to put tubes that contain various gases in it, and then it's going to send electricity through that gas to excite it and make it glow. And then we're going to examine that through our diffraction grating. And we're going to start by looking at helium. So now that we have the diffraction grating over the camera lens, what you should be able to see now is a series of vertical lines of color. So elements and specific compounds will emit just certain wavelengths of light when they are excited. So when you're drawing the spectra for helium, we should really have like one red line, one yellow line, looks like a couple of blue lines, and at least one purple line. So take a minute to pause the video if you need to and sketch that spectra. The next element here we're observing is hydrogen, and you can see just on its own, it's got kind of a pinkish purpley glow to it. Now with the diffraction grating over it, we can also see that we get those distinct vertical lines of color in its spectra, although this time it just looks like there are fewer than there were for helium. So there's like a bright red one, a blue one, and then at least one purple one there at the end. Pause the video if you need to and sketch the spectra. The next element here that we're observing is krypton, and you can see here that it's got a very, very pale purple, almost white kind of glow to it all on its own. The spectra of krypton tends to be a little on the faint side. So what you're not seeing here in the video is that there is actually a faint red line to the right of the orange, and there's a second faint dark green line to the left of that light green line. So add those into your spectra drawings as well. Now here we have the bright and probably familiar red glow of neon. And now let's see what it looks like through our diffraction grating. So when we look at neon here, we can see that it has mostly lots of lines in the red, orange, and yellow sections of the spectra. And what you probably can't see is that there's a couple of very faint green lines.